Passage 4. Page 182. Questions 7 and 8. Listen to part of a lecture in a meteorology class.
So now let's talk about another weather phenomenon that can do great damage, but one that we are also getting better at understanding and predicting, though not so much at preventing. I'm talking about hail. Now, hail is just frozen droplets of water, but the process by which water turns into little balls of ice that plummet from the sky and destroy roofs, windows, and crops, well, this process is one of those things that is actually a bit more complicated than we used to think. Hail starts in cumulonimbus clouds, which you will recall are very tall clouds indeed, as tall as 6 miles in some cases. Because they're so tall, they're much warmer at the bottom than at the top. This warm air creates updrafts that blow drops of water higher and higher into the clouds. As these drops become supercooled, they will freeze on contact with ice or dust particulates. Now, it used to be thought that these frozen droplets would descend through gravity or downdrafts, then get pushed back up into the cloud by updrafts, and finally gather more water and refreeze. But due to recent research, it appears that it's more complicated than that, with hail forming not just within the interior of the cloud, but possibly on the backside of the storm. The humidity of the air that the hailstone is passing through, and whether the humidity is liquid water or vapor, also have an effect on the rate of growth of the hailstone. In fact, it will also have an effect on the appearance of the hailstone. If you've ever seen a hailstone split open, you've probably observed that it's kind of like an onion because it has several layers, and these layers are different from each other as well. That is, some of the layers are clear, like ice cubes from your freezer, and some of the layers are white ice, I guess, again, like the frost that collects in your freezer. Now, why are the layers different? This is all part of the complexity of storms that I find truly fascinating. You see, it depends on the form of water that is surrounding a little hailstone when it gets pushed by updrafts higher into the air. If it comes into contact with liquid water droplets, the water condenses on the hailstone and freezes, but not so fast that bubbles of air don't have time to escape. This process forms a transparent layer on our little hailstone. However, if the water is in the form of supercooled vapor, it will freeze onto the hailstone so fast that air bubbles are trapped and make the layer white. Okay, so in a minute I'm going to talk more about the latest research into hail formation. You know, some people find it so annoying that just when we think we understand something, along comes some evidence that blows apart all of our carefully conceived ideas of how things work. As a researcher, I personally find this constant adjustment of what we know truly inspiring. There's always more to find out, and I can continue in my job for the foreseeable future. Okay, back to what I was saying. Other new developments have come in the form of imaging devices that can identify what is likely to be hail within a storm system. And again, as I said, we found hail in places we didn't used to think we ever would. Right now, we can predict the likelihood that any one area will be experiencing hail with radar and weather models. However, it's only a matter of years until we'll have the models and equipment in place to definitively say where the hail is. As for prevention, my next point, obviously the old medieval practice of firing cannons or ringing church bells has not proven terribly effective. Way back then, people were hoping that the blast waves from one or the other of these would break up the hailstones. And, oddly enough, there are modern versions of cannons that have been used. If you're curious, you could search for some pictures of those. I apologize, I forgot to bring some to show you. Needless to say, any of those neighbors who have had to endure repeated cannon blasts from the time the storm approached until it passed are probably on the front lines of those who question the use of big guns like a hail cannon. And this lack of proven effectiveness also goes for the practice of shooting the chemical compound silver iodide into clouds to prevent the formation of hailstones. It's just not backed up by solid evidence. In contrast to now having better prediction and localization techniques, I see hail prevention as remaining out of reach for a long time to come.
Number 7. Listen again to part of the discussion. Then answer the question.
Some people find it so annoying that just when we think we understand something, along comes some evidence that blows apart all of our carefully conceived ideas of how things work. As a researcher, I personally find this constant adjustment of what we know truly inspiring. There's always more to find out, and I can continue in my job for the foreseeable future.
How does the professor feel about changing his ideas due to new evidence? Number 8. What is the professor's attitude toward hail prevention?